let's talk about diffusion and osmosis. In diffusion, we're going to see solutes move. And in osmosis, we're going to see water move. So the way that we illustrate this is we're going to start with a beaker that has a semi-permeable membrane. That reminds us of a cell with its semi-permeable membrane. Now in this beaker, we are going to add some water. And we are going to put in some solutes. Now, solutes are always illustrated as dots. Now, we'll have more solutes on one side of the semi-permeable membrane than we have on the other. In the case of diffusion, solutes are going to move until they are equal on both sides. So we draw this little arrow to say time has passed, and we'll draw our beaker again now that time has passed. We'll draw our semi-permeable membrane. We'll have our water. But now we'll see that we will have an equal number of solutes on each side of the semi-permeable membrane. This means that our solution is equal. As you can see here, one of these solutes has crossed over that semi-permeable membrane to the other side as time has passed. Now, what's going to happen in osmosis? Osmosis, only the water can move, not the solutes. So once again, we'll draw our beaker and we'll draw our semi-permeable membrane. This time, we are going to have our water, and we're going to have our solutes. And that looks similar to what we saw in the first beaker here. So now let's see what's going to happen over time. Remembering that the dots or solutes cannot move, only the water can move now. So what we're going to have over time is our beaker with the semi-permeable membrane is going to look a little different, with more water on the side with more solutes and less water on the side with less solutes. The solutes have not moved. But now we will have an equal concentration of solutes on each side of the semi-permeable membrane. That's the difference between diffusion and osmosis. Now, every time we talk about osmosis, we're also going to talk about tonicity. Tonicity is simply having a hyper, or isotonic solution surrounding your cell and predicting what can happen to the cell based on the solution around it. So we're going to draw out 3 beakers. And in each of these beakers, we are going to put water, solutes, and a cell. So imagine these are our beakers. And in our beaker, we have our water, we have our cell. For each of the cells, we're going to illustrate 4 solutes. Now, because there are 4 solutes in each of the cell, we need to figure out what type of solution we have. So we'll label this solution a hypotonic solution. So what does that mean? Well, hypo means less than, which means that the solution will have less solutes than the cell. So when we illustrate our solutes in the solution, we'll just draw less than 4. In our next beaker, we'll make this one an isotonic solution. And iso means same, which means we'll have the same number of solutes in our solution as we have in our cell. And in our last beaker, we're going to call this the hypertonic solution. Hyper means a lot of. We will have more solutes in our solution than we have in our cell. Doesn't matter how many you illustrate as long as there is more than what's inside the cell. Next, what we have to do is determine how does the water move. Remember, this is referring to osmosis. And in osmosis, only the water can move. It's trying to equal out the concentrations. As a general kind of quick tip, the water will always move to wherever there are more dots or solutes. So in the case of a hypotonic solution, the water is going to move into the cell. And when the water moves into the cell will swell. It sometimes can swell up so much that it bursts or lyse. In an isotonic solution, we have the same number of solutes in the cell as we have out of the cell, which means the water will move in and out at an equal rate, and the cell will stay the same. In a hypertonic solution, the water wants to move wherever there are more solutes, which means that water is going to move out of the cell. And when water moves out of the cell will shrink. Now think about how this would pertain to cells in your body, such as red blood cells within the fluid that is your blood. If we wanted to build up fluid in the blood, we would need to give you IV fluids, and we would want those fluids to be isotonic to your cells, because we do not want to change the structure of your cell by having it swell or shrink, because if we change the structure, we change the function. Therefore, it is always best to give an isotonic solution so that the cell remains the same.